Hi friends, myself Arvind from Department of Electronics and Communication Engineering, Rajiv Institute of Technology, Hassan. Today I am going to make an explanation about the calculation of linear convolution using Scilab. Let us go through a problem. Find the linear convolution of the sequence x of n equals 1, 2, 3 and the system having the impulse response of h of n is equal to 1, 3, 6. Getting into the solution. So let us first find out what is the length of the given sequences. The length of x of n is 3 and length of h of n is 3. Now calculate the output sequence length, capital letter N, given by length of x of n plus length of h of n minus 1. So these two lengths are known values. So that is 3 plus 3 minus 1. So output sequence length is going to be 5. Now the formula for the linear convolution is given by y of m equals summation n is equal to 0 to n minus 1 x of n h of m minus n. Since we are going to have total output sequence length is equal to 5, the m is going to take the range for this particular case between 0 to 4, making the assumption that the first element in both the inputs are the origin. Now calculating at each value of m, at m is equal to 0, we are going to calculate y of 0, that is equal to summation n is equal to 0 to 4 x of n h of 0 minus n. Expanding this summation, we are going to get x of 0, h of 0 minus 0, x of 1, h of 0 minus 1, x of 2, h of 0 minus 2, x of 3, h of 0 minus 3 plus x of 4, h of 0 minus 4. Now making solution for this, we are going to get this realization. Now substituting the values for the available representation. So that is among all these expansion, we are going to have the values only for x of 0 and h of 0. Whereas for h of minus 1, h of minus 2, h of minus 3 and h of minus 4, we don't have any values. Therefore, all those will be substituted as zeros. So 1 into 1 we are going to have over here and the result is 1. Similarly, at m is equal to 1, we are going to get y of 1, that will be equal to summation n is equal to 0 to 4 x of n h of 1 minus n. Now expanding this summation, we are going to get this realization and making the substitution for that, we are going to get the answer as 5. Now continuing that for the values of m is equal to 2, 3 and 4, we are going to get the corresponding results 15, 21 as well as 18. So procedure we need to follow, the expansion has to be done and then substitution and then we are going to get these values. So finally the resultant value y of m will be equal to 1, 5, 15, 21 and 18 with first element itself as origin, because in both the given inputs first element itself is the origin, therefore in the resultant also first element itself will become the origin. Let us move on to the Scilab code for linear convolution. The code is making use of the inbuilt function of the convolution. So let us go through line by line. So the first sequence x is equal to 1, 2, 3, that is defined, and the impulse response h is also defined 1, 3 and 6. Then we are making use of the convolution function. Here it is given by convol, that is convol y is equal to convol of x comma h, convolution being done between these two sequences. And then the convolved sequence will be stored in y and we are displaying the values of y on the console window. Now the next part is going to plot the output sequence on the graph. So output length is given by capital letter N is equal to length of x plus length of h minus 1, the same what we have used in the calculation part. And then we are going to have a plot 2D3, that is the discrete plot, the x-axis ranging from 0 to n minus 1, and then the y on the y-axis we are going to plot. And this 3 is going to represent the color of the lines that is going to be obtained in the discrete plot. And these are the x label, y label, and the title of the graph. Now let us make the execution of this one. So first let us go through the console window. So the convolved sequence y is being represented here. It is 1, 5, 15, 21 and 18. The same we are going to obtain in the graph also. So let us go through the graph. As we can observe here, the graph is being represented only for the output. At location 0, the output is 1. You can observe the change in the color of the line, that is equal to 1. So that's what this 1. And then second value is 5. At location 1 it is 5. And then at location 2 it is 15. Location 3 it is 21. And at last it is equal to 18. Thanks for joining.